Hello everyone and welcome to Coding Card. So in this tutorial we are going to solve one lead code problem from the topic linked list, and you can see here the problem name is next greater node in a linked list. So in this problem we will be given one linked list, and what we have to do here is for each node we have to find the next greater node. So let me explain you here with one example. For example, the linked list is having value 215. Suppose here we are given one linked list having value 2, 1 and 5. So what we have to do here is for each node we have to find the next greater node. So here for 2 the next greater node is 5. For 1 the next greater node is again 5. For 5 we don't have any next greater node. So for this we have to return 0. So you can see here the output 550. 550. Let's take this example 27435. Linked list having value 2, 7, 4, 3 and 5. So for these two the next greater element is 7. So we will place 7 for these two. For 7 you can see here in the whole node we don't have any next greater element, so we'll simply put 0 over here. For 4 the next greater element is 5 here, so we'll put here 5. For 3 again we have 5, and for 5 we don't have any next greater node, so we'll simply put here 0, and at the end we have to return this one as our answer. So answer is 70550. So you can see here 70550. So this is the problem here, means here we will be given one linked list, and what we have to do here is for each node we have to find the next greater node, and if next greater node is not present for any element then we have to simply put 0 over there. So how to solve this problem? So let me explain you here with this second example. Linked list having value 2, 7, 4, 3 and 5. So for this problem we have to simply use one stack. We have to use one stack, and we know stack has two operations. One is push operation and another is pop operation, and I will explain you how this stack is useful here in this problem. And here for push operation we have two things when we can push element into stack. The very first criteria is either the stack should be empty, the stack should be empty, or second criteria is this is or second criteria is the next upcoming element should be less than the element which is at the top of the stack. Means upcoming element, let me first write the criteria, then I will explain you with the example. Upcoming element should be less than topmost element. Top element, top element in the stack. And for pop operation we have again two things. When we can pop elements from the stack we have two criteria. First one is stack should not be empty. Stack should not be empty. And the second criteria is the upcoming element should be greater than stack topmost element, top element from the stack. So for stack we have two operation, push and pop, and when we can push the element, either stack is empty or the upcoming element in the stack should be less than the topmost stack element. And for pop condition either the stack should not be empty, and at the same time the upcoming element should be greater than the topmost element which is present in the stack. So let me explain you here with the same example. Our list is having value 2, 7, 4, 3 and 5. Now let us take one stack. Now you can see here currently our stack is empty. Since the stack is empty we can simply push the value 2 here. 2 is done. Next is 7. Now the upcoming element is 7, and the stack topmost element is 2. So whether we can push 7 or not, so for push operation, you can see stack should be empty, or here currently stack is not empty, so it will go in or condition. Here the upcoming element should be less than the stack topmost element, means this upcoming element should be less than the stack topmost element. So here you can see here 7 is not less than the topmost element, so it want to go for the push operation. We'll go for the pop operation now. Now for the pop operation, you can see here stack is not empty, yes, or stack is not empty, and at the same time, what is the criteria? Upcoming element, which is 7, should be greater than the topmost element in the stack. The topmost element is 2, yes, this criteria is satisfied. So for these two, we'll simply pop out these two, and for these two, the next greater value is 7. So whenever this upcoming element value is greater than the stack topmost element, then that upcoming element is the next greater element for this stack topmost element. So previously 2 was the stack topmost element, so its next greater element is 7. So 7 is the element which made this value to just pop out. Now our stack is empty, we'll simply push this in our stack. Now we are done, we will move forward. 7 is done, we will move forward. Next is 4. Now you can see here the upcoming element is here 4. Now here my stack is not empty, it will go for OR condition and will check whether the upcoming element is less than the stack topmost element. Yes, it is true, then go for the push operation 4. Now we'll go next is 3. Next is 3, again our stack is not empty, it will check this condition, upcoming element which is 3, it is less than the stack topmost element. Here topmost element is 4. Yes, it is true, so it will again go for the push operation. It will go in the stack, and stack topmost element will be now 3. Now we go to the next element which is 5. Now again my stack is not empty, it will check the next criteria which is upcoming element 5 is less than stack topmost element 3. No, this is wrong. So it will go for the pop operation. Now for the pop operation, it is checking whether stack is not empty. Yes, my stack is not empty, and at the same time, it is checking whether my upcoming element is greater than the stack topmost element. Yes, upcoming element is greater than the stack topmost element. So what we will do here is we will assign 5 as the next greater element for this stack topmost element. So for these 3, the next greater element is 5. And what we will do is simply pop out this element. Now my stack topmost element is 4. Now again it will check whether this stack is empty. No, my stack is not empty, and at the same time upcoming element which is 5 greater than the stack topmost element. Yes, 5 is greater than 4. So what we will do, this 5 will be the next greater element for the stack topmost element. So stack topmost element is 4 and its next greater element will be 5, and we will simply pop out this element. Now again my stack is not empty, and at the same time we are checking upcoming element 5 is greater than stack topmost element. Stack topmost element is 7. So this criteria is false. So if it is false, what we will do, we will simply push this into stack. So 5 will be here. So here we are done. We are at the end of the linked list. We are done here. Now when everything is over, we are simply going to assign 0 for the element which we are not able to find the next greater element. So at the end we will simply return this as our answer. So this is the problem here. We are simply using one stack data structure to perform this operation. So now in this problem we have to take care of two things. One is the stack data structure and another is the index thing. I will explain you this one here. Like whenever we are getting a next greater element, we have to assign that next greater element to the stack topmost element. So how to find the location of that stack topmost element? Where is that stack topmost element present? So for that we will save the value as well as the index part both in the stack while doing the push operation. So let me explain you here with the same example again. Let us take the same example 2. 7, 4, 3 and 5. Suppose this is our linked list, and we will take one resultant list to save our next greater element. So if you see here, just think this is an array having index 0, 1, 2, 3 and 4. Suppose this is 0, 1, 2, 3 and 4. Now we will take one I equal to 0 as a counter. So whenever we are moving one by one node, we'll simply increase this by +1. Now currently we are at the very first node. So what we will do, we'll assign 0 for its index. Whenever we are moving node by node, we'll simply go and assign 0 to its corresponding position. And with the help of this stack operation, what we will do, we will place the correct next greater element to its corresponding position. So I'll explain you here. So currently we are at the node 2. So we will place here 0 at index 0 here. Currently I is 0. Now my stack is empty. So what we will do, we'll place the value 2 and the index value 0 in my stack. Now we'll move forward. We'll place here 0 first. Now here the upcoming value is 7 and the stack topmost value is 2. So for push operation, the upcoming value should be less than the stack topmost element. But here the criteria is not true for the push operation. So it will go for the pop operation. So for the pop operation, what we are going to do here is, here 7 will be my next greater element. For which one? This value 2. And 2 index is where? At 0 position. So go to the 0 position and place value 7. Correct? It is working fine now. Now what we will do? We'll pop this from the stack. My stack is empty. So what we will do? We'll simply press 7 and its corresponding index, which is 1. 7, 1. We'll move forward. Next is 4. So first place here 0. Now upcoming element is here 4. So 4 and the stack topmost value is 7. So is 4 less than the stack topmost element? Yes, it is less. Then go for the push operation. So we'll simply add here 4 comma and its index is 2. We are done here. Now here stack topmost element will be 4 now. Now we'll go for the next node, which is 3. First we'll put here 0. Now here the upcoming element is 3 and the stack topmost element is 4. So we'll check, is 3 less than the stack topmost element? Yes, it is less. Then go for the push operation here. So here we'll simply push this 3 with its index 3. Now the next element is 5. So go to 5. First we'll place here 0 at its index. So whenever we are going node by node, we are simply increasing this I by I plus 1 by +1. I will write the code. You will able to understand easily over there. Now here stack topmost element is 3 and the upcoming element is 5. Is 5 less than the stack topmost element? No. Now here it will go for the pop operation, and for the pop operation my stack is not empty and here my upcoming element is 5. So 5 will be the next greater element for this value 3. So go to the index 3. This is my index part and this is my value part. So go to the index 3 and place 5. Go to the index 3 and place 5. This upcoming value over here. Now this will be popped out. Now my next greater element is 4. Again my stack is not empty and the upcoming value is greater than the stack topmost element. This 5 is greater than 4. So again what we will do, go to index 2 and place this 5. Go to index 2 and place this 5. So for the stack topmost element, my next greater element is the upcoming element, which is 5. So we are going to the corresponding index and placing 5. And after that, this was 5. After that, we are simply popping out that element. Now my stack topmost element is 7. Again, my stack is not empty and we are checking. For the pop operation, we are checking the upcoming value is greater than the stack topmost element. So this is not true. So what we will do? We will simply push this element here. So 5 comma and this index is 4. 5 comma 4. Now we are done. We are done with the linked list. So at the end, if you see here, we have got our result here. We'll simply return this result. You can see the answer is 70550. We are getting the correct. So in this problem, we have to use two things. One is the stack and another is the index part, so that we can place the next greater element to its corresponding index. So let me write the code and explain you again line by line over there. So here what we have to do here is we have to take two things. One is the resultant list to return the result. Another is we have to take one stack, and one is the I value. So whenever you are moving from node to node, this I value will be increased by 1. And let us take one pointer ptr to iterate in the linked list node by node. So ptr equal to head. So till here everything is okay. So what we will do, we will iterate in the linked list from start to end. So for that, let us use one while loop. While ptr is not none, we are going to iterate one by one. Now whenever we are reaching to the very first node or second node or any node, our first task is to place 0 in our resultant list. Means we are standing at, means if you are standing here, our very first task is to place 0 at its corresponding index in the resultant list. So what we will do, we'll simply place res dot append 0 over here. Now next target is to write the logic for the push operation. So what we will do here, logic for push operation. Okay, so what is our very first task? We have to check whether the stack is empty or not. We will check if length of stack, we will check length of stack equal to 0 for empty, or at the same time what we are going to check, you can see here the criteria, stack is empty, this one, stack is empty, and at the same time upcoming element. So upcoming element is ptr dot val, it should be less than the stack topmost element. It should be less than stack topmost element will be -1. It will give the topmost element, and we have to consider the value part. So you can see here in the stack we are pushing two things. Here we are pushing two things, value part as well as the index part in a stack. So suppose we are here, suppose this is my stack topmost, so we can simply get by stack -1, it will give this value, and from this one how to get the value part, this 5 we'll simply get by bracket 0. Okay, it will give the value part. If you put here 1, it will give the index part, so 0. If this criteria is satisfied, what we will do, we'll simply push the value into the stack. So stack dot append two things. One is the value part, so ptr dot val, and at the same time we are passing the index part, and index is calculated with the I, so we'll pass here I. So this is the logic for the push operation. Now if the stack is not empty, or the upcoming value is also not less than the stack topmost element, so it will go for the pop operation. So we'll write here logic else, here we'll write the logic for pop operation, correct? In else part we have to do the pop operation. So for the pop operation we have to perform till the stack is not empty, and at the same time the upcoming value is greater than the stack topmost element. So for that we will write simply while loop, while length of stack is greater than 0, and at the same time the upcoming value ptr dot val it should be greater than the stack topmost element. Stack of -1 will give me the topmost, and topmost element is containing two things, so we have to first check the value part, so 0. So till this condition is satisfied, we are doing pop operation for every stack topmost element. So what we have to do here is, whenever this criteria is satisfied, so what we have to do, we have to get the index part from the stack topmost element. So how to get the index part? So for that we have to write stack of -1 to get the stack topmost element. Now from the stack topmost element, it is containing two part. One is the value and another is the index part. So index part is at 1. So this will give us the index. So this will give the corresponding index where we have to fit that next greater element, which was the upcoming element. So we have to go in RES, we have to go to this index and assign the value the upcoming element, which is ptr dot val. Okay, so let me explain you this line here. It means, suppose in the stack topmost element here, suppose we are having value 3 comma 3. This is my stack topmost element. So this is my stack. So if I write here stack of -1, it will give 3 comma 3 like this. Now here I have to access, this index part. So what I will write, a stack of -1 and 1. It will give, this total value will give me 3. So we have to use this index in our res of 3. So it will go in this res at index 0, 1, 2, 3. It will go here at index 3 and we are assigning ptr.val, the upcoming value here. Suppose the upcoming value is here 10. So it will go at index 3 and assign 10. So we are writing the same over here. So after assigning this value, our next target is to pop the stack topmost elements. So we'll simply use stack.pop. So this operation will be done till this while criteria is satisfied. So once this criteria is fail, what we will do, we will go down and write our next target is, whenever this criteria is fail, our target is to push that upcoming element into the stack. So stack dot append the upcoming value, which was ptr.val, at the same time its index part I. Okay, so we are done. So till here our logic is over. Okay, so till here our logic is done. Now next target is, we have to move to the next node. So let us write the logic for this while loop for the ptr. So ptr will be ptr equal to ptr dot next. So whenever this if condition, if and else are done, we are moving forward to the next node. So that's why you're writing here ptr equal to ptr dot next, and I value will be increased by 1, I plus equal to 1. So our this I value will be also increased by 1 whenever we are moving to the next node. So we are done, and at the end, whenever this criteria is satisfied, we have to return the head. So we are done. So let us run this code. Oh, here we have made one mistake. We have to return here result, res, not the head. So you can see here it got accepted. So you can try for the next sample input, which is 2, 1, 2, 7, 2, 7, 4, 3 and 5. Let us run and check. So you can see here the output 70550. So it is working fine. Let us submit this code. So you can see here it got accepted. So that's all for this problem. So basically here two things were used. One is the stack operation and another is the index part. Means we have to place the next greater element to its corresponding position. So that's all for this problem. So I hope you have understood this logic and the explanation. So if you have learned something new, please do like our videos and subscribe to our channel Coding Cart, and stay tuned for the next videos. Thanks for watching.